Good morning, good afternoon, or good evening. A warm welcome to everyone, wherever you are in the world. Crew are very pleased to be hosting this ICL webinar on water-soluble fertilizers with industry experts Brian Mann and Christi Falen. For those of you who don't know me, I'm Simon Inglethorpe, the editor of Fertilizer International magazine. The format of today's 45-minute webinar is firstly a brief scene-setting intro from me. I'll then be handing over to our two presenters, Brian and Christi, for about 30 minutes. Brian will then lead 10 minutes of Q&A, and finally I'll reappear at the end for some concluding remarks. Okay, coming back to today's theme, water-soluble fertilizers are a fascinating topic for many reasons. For me, they are pathfinder products that illustrate the move from volume to value that we're seeing in the market right now. Their adoption is certainly part of a wider shift within the global fertilizer market to more lucrative specialty products. While growth in water solubles has been driven by the adoption of drip irrigation and greenhouse growing, other factors such as the need for crop yield and quality improvements and better nutrient use efficiency are also key drivers. So in more detail, what will today's webinar actually cover? Well, our key theme is how water-soluble fertilizers, beyond simple crop nutrition, are becoming precision tools for efficiency and sustainability. In particular, this webinar will highlight how pH management unlocks nutrients already present in the soil and how this improves fertilizer efficiency, helping growers in producing more from less. Finally, we'll learn about how three product innovations from ICL, Agrolution's pHLow, PeKacid, and Bioz, and how these are driving agronomic results and sustainable business outcomes. Moving on, I'd like to introduce and welcome our two expert speakers. Firstly, Brian Mann is ICL's North American product lead for water-soluble fertilizers. He has in-depth knowledge of the application and crop benefits of water-soluble products. At ICL, he provides comprehensive business support to customers, and as an agribusiness leader, Brian brings more than 15 years of experience and passion to the team. Our second speaker, Christi Falen, is ICL's product lead for biostimulants and foliar products. She brings to ICL 25 years of agronomic expertise in plant nutrition, crop protection, and agricultural extension. In her role, she helps growers enhance crop productivity for both irrigated and dryland systems. Brian and Christi, I'd like to hand proceedings over to you. Thank you very much.
Thank you very much, Simon. Appreciate it. Glad to be here. So I thought we'd start with a little bit of background, a little bit more information about ICL as a whole. We just passed our 100 years as ICL. Growing Solutions is just one business unit, part of a very large and diverse phosphate and potassium-based products, anywhere from food additives that are in Coke, Pepsi, and other things, and in our bromine division that is basically in almost any product that you could look around and wherever you're sitting, there's bromine in there, as well as our potash division. So we're very diverse, very large. In Growing Solutions, our agricultural division is only one small part of a very large company. So next we're going to talk about what is driving the shifts in water-soluble growth. And you know, I'm not going to speak globally because my expertise is more in North America, but I think some of these concepts definitely apply. We're seeing a continued push for growing more with less. And Simon made a good point. His point of volume to value is very much in that same vein. And we are seeing that in the North American market as growers seek more precision, more control, and more sustainability. So as the precision irrigation continues to expand, it's a key driver for the expansion of the water-soluble market as well. So as as precision ag growth in the United States is tied to, say, drip irrigation on the West Coast is very large. We're seeing it in Michigan, my home state, on the West Coast. All new acres of the specialty crops going in are all on drip. It's opening up new opportunities in our markets to get these advanced water-soluble fertilizers into the market. So growing more doesn't always mean adding more. One of the concepts that we have really focused in on here in the United States is unlocking what is already tied up in the soil. Using pH to unlock stuff at the right time to improve plant growth. And we have leveraged our PeKacid technology, a water-soluble O6020 low pH product that's compatible with calcium, to help drive that type of growth here in North America. And at this point, I'm going to turn it over to Christi, and she's going to do a deeper agronomic dive into how we're utilizing pH as a way to help the industry in water-soluble fertilizers.
Thanks, Brian. So our water-soluble fertilizers are positioned to where we can address not only soil pH issues and influence our nutrient availability in that manner, but also by addressing water pH and or water quality issues as well. Because ultimately, we're after increasing the solubility of the nutrients so that we can increase the uptake and we can reduce or minimize the losses, because we're after, as is mentioned, higher nutrient use efficiency. So sort of the idea of doing more with less. So as we start thinking about this, in the diagram on the right, for all of you that are familiar with the agronomic aspects of it, you know, we've known this for years, that the soil pH really influences the nutrient availability, not only the macronutrients, but the micronutrients as well. As we have the higher pH of our soils, and we get above 7.5 and 8.5, you can see severe restrictions that come into play. So what we're after is how can we reduce that soil pH there down to 6.5 to 7. But when we do that, we're not after trying to change the whole soil. The base soil of everything across the board would cost too much. It's constantly trying to go back to its natural state. But what we really can do is we can influence the soil pH in the rhizosphere or in the root zone. And by doing that, we can improve the nutrient use efficiency. We have been fertigating here in the West and many places around the world. As we do that with the acidifying water-soluble fertilizers, we're being much more precise and really are seeing some very good responses that you'll see later when I show you some of the data. In addition to that, we're expanding out where we're doing more and more, where we have like maybe dryland corn and soybean acres that they haven't been able to utilize the water-soluble fertilizers and the benefits. So we're putting the precision placement in bands and starter fertilizers for those as well, and seeing some really good benefits on a nutrient use efficiency standpoint. So the other piece to the puzzle is the soil. You know, we know that, but in addition to that, it's the water quality and being able to have the systems when we're irrigating that are working well and effective. You know, when we have, as you see the pictures here on the right, when we don't have good compatibility or we have buildup within those systems, then our nutrient and water use efficiency both go down. So we want to have compatibility, as we see here on the bottom left, with the PeKacid compared to a competitive product, where we can mix things together and we don't have the buildup. We don't have the systems, the irrigation systems needing additional maintenance or replacement. So we can have both environmental and economic losses that can happen if we don't utilize the right sources. So the PeKacid technology is really strong, and it helps us, here you see in the 3 major different ways. We can lower the pH of the soil, we can neutralize the bicarbonates and help save our irrigation system, and we can also enhance the nutrient availability, not only of what we're putting on. In the example of a Nova PeKacid dry, it's a 0-60-20. So the producer can pick the nitrogen source they want, but as we reduce the pH in that root zone, we enhance the nutrient uptake of all of our nutrients, as we saw in that first picture. We are continuing to provide choice for farmers, retailers. So the Nova PeKacid we've actually put into a liquid. So that's this one here in the middle of the LQ. And then our Agrolution pHLow line would be a total NPK and micro package, different ones that would come with it. So there's choice as far as what they can use depending on which fits their operations. So, you know, when we start thinking about the pH management, it's not just a soil conversation. It's more of really a soil, fertilizer, and nutrient use efficiency and water savings or water use efficiency discussion. You know, we want to think about what we can do where we can have the most sustainable production from an environmental standpoint, but also a profitable system. So if we can stack benefits together, and we can innovate where we can feed the crops and we can manage the pH and we can improve the efficiency, as well as providing compatibility to the growers and providing a choice or flexibility, then that becomes the conversations that we're starting to have and have been having. So this just gives you an example of a few of the products and thinking about versatile formulations and precise nutrition, you know, utilizing the 4 R's that we put in place. And you can see the Nova PeKacid 0-60-20 that I mentioned, as well as the liquid version of it at 0-27-9 or a 4-17-4 option with Nova PeKacid, and then the dry Agrolution pHLow 11-45-11 with the 2% zinc. Those are a few of the ones that we will talk about a little bit more today in depth, where we can utilize these for both the starter, fertigation, and we can mix them, the PeKacid technology for these right here at the top, we can mix them with calcium. And then we can start to think about mixing them with biostimulants or enhanced nutrition fertilizer as well. So if we start looking at some of the data, you know, obviously we don't have time today to go through all of it, but we'll kind of highlight a few of them for you. So we have seen yield increases with our Agrolution pHLow. I mentioned at the beginning that we've fertigated with these for a long time, but here in this case, we're utilizing it as a starter fertilizer for more row crops, and saw yield increases across potatoes, corn, soybeans, and sugar beets. Additionally, with those products, we've seen 2 to 4 times less P2O5 that we have to put on, so an efficiency perspective. And then we've utilized the Agrolution pHLow 6-31-31 through fertigation for our specialty crops as well. So overall, we have a lot of different choices and some definite yield and quality benefits and nutrient use efficiency and economics that we've seen. So let's look at a few of the crops a little bit more, where you can see some of the data that backs it up. For corn, we see that optimized phosphorus use efficiency when we have the 11-45-11 put on, 4.4 times more efficient with an Agrolution pHLow compared to 10-34-0 liquid. And then you can see the yield responses here that we were getting compared to the control. So not only are we having an economic benefit we're also having an environmental benefit because of utilizing less phosphorus and producing more than what we had with a conventional product. We swapped to potatoes, and in a similar example, we have a higher rate that we have to put on for this particular area. This was in Michigan. So we still saw 3.5 times less phosphorus that we had to utilize here. So we're talking about 79 units of P2O5 for the conventional, what would be utilized with 1034O, compared to only 22.5 units of P2O5 with the Agrolution pHLow. On the soybeans, this one is actually with our PeKacid, our Nova PeKacid. You see the grower standard, our PeKacid being significantly higher with only 6 pounds to the acre. So it was a 13% yield increase or an 8 bushel increase on soybeans in Louisiana with an acidic fertilizer as a starter. Okay, and then I'm going to utilize this pear example to show you. We did a pear trial in Oregon. We did it for 2 years. It was in a commercial orchard. And this backs up what previous research had shown when we looked at it with a straight PeKacid. All of our Agrolution pHLow products do contain the PeKacid technology. So when I'm talking about the Agrolution pHLow 114511 or the 63131, those contain the PeKacid technology. So here we put on the irrigation, we fertigated it on, and we had a total of 9 applications that we did at 13 pounds per acre for each time that we fertigated. Okay, and then I'm just showing you the 2023 data, but we saw the same thing in 2022. If you look at this bottom left box, and you think about the quantity of P2O5 or K2O that we're putting on, with those 13 pounds per acre and the 9 applications, we were actually only putting on 36 pounds per acre of P2O5. There's a lot of variation that always happens, and back and forth, different soils will react differently, but overall you'd assume from what we knew that we would have raised the soil pH by 2 parts per million. Much the same way we would have assumed that we would have raised the K2O by 3 parts per million. So if you look at this upper left-hand chart, you can see the pHLow, the pH. We didn't hugely decrease the pH from 6.8 for the control down to 6.7. But look at what we did with the phosphorus. We went from 56 parts per million to 98. And on the potassium, we went from 242 to 433. And then on the right-hand side, we have a lot of calcium carbonate in our soils. So you can see here that we actually reduced the calcium levels with the pHLow compared to the control. So in that case, that's very good because we're actually making the nutrients much more available. So by putting on that small amount, we had a huge influence from the soil standpoint. And this is within the rooting zone, or I would say the rhizosphere. These soil samples were collected from 8 inches along the tree line where we had fertigated. So a precise application. So when we think about what that precise application did for the grower, we can see a statistically significant yield increase. We went from almost doubled the yield. So a very economical return from that precise application for the grower. And then the additional thing that we found is as we had made sure that we had very good nutrition and we had very healthy trees, they actually produced fruit that was more firm than the grower standard as well. So we had made a benefit on not only the yield, but on the quality, and much less from an environmental standpoint as far as the amount of nutrients that we had put on. So when we think about it, you know, we start seeing, as we've done so far, and we'll continue to see, both an economic and agronomic and an environmental benefit by being able to reduce those rates and maximize the efficiency where we can grow more with less. So these examples, there's a lot on the slide. I'll break it down for you. Big pieces here is you look at the marketable yield on the potatoes is on the left hand side, and you can see with this first group of bars in Wisconsin with the russet Burbank, you don't see a statistical yield increase. For the control is a gray bar. The 1034O, or ammonium polyphosphate, APP at 10 gallons per acre, is this lighter blue, and then the dark blue is the Agrolution pHLow at 10 pounds per acre. You do see in Michigan a statistical yield response based on source with Manistee, that's a chipping variety, versus russet Burbank. Then here you can also see a yield response when we can increase with the russet Norcotas, which is a variety that isn't normally as responsive. We still see that there was a fertilizer source response. But when we don't see a fertilizer response to the yield, does that tell the whole story? So I think we really need to look at not just one piece to the puzzle. We need to dig a little bit deeper. And as we dig a little bit deeper, we think about the context again, much like we saw with the pears, where we see that we have 4.5 pounds of P2O5 compared to almost 40. So a huge difference there. Also a difference in cost, thinking about $16 versus $39 per acre for a cost to the grower. Not only that, when we think about the agronomic benefits and the environmental or sustainability aspects, when we subtract off the baseline soil fertility levels, we look at the efficiency of what we were able to gain with the Agrolution pHLow. The light blue bar again is the 1034O, or ammonium polyphosphate, and then the dark blue bar is the pHLow. Same varieties, and looking at it from, here's your Wisconsin in the middle, then we go to Michigan, and then we go to russet Norcota in Michigan. And we see that we, excuse me, we go with anywhere from 11 to 14 times more efficient on the amount of potatoes that we are able to produce per unit of phosphorus that we apply. So that's good on all three fronts: economic, agronomic, and sustainability or environmental. So what's the next step as we start thinking about where do we go from here? We know the nutrition, we've built on that, so we have to go to the next step. As we do that, and we've done that like we did with our water solubles with the PeKacid or the Agrolution pHLow, then we can start thinking about adding enhanced efficiency fertilizers or biostimulants as the next missing link for influencing both the plant morphology and the plant physiology, the soil microbiome, so that we can be able to continue to advance and innovate. So as we do that, we start thinking about what can we do to enhance the plant physiology. Like I mentioned, the soil microbiome, how can we feed the microbial life in the soil, and what can we do to get even better nutrient use efficiency. So we talked about earlier where we're looking at precise placement into the root zone or when we're banding with the fertilizers. But overall, when we think about those interactions of where we need to be and the precision of it, we need to think about what's going on in that rhizosphere. When you look at the diagram on the left and you think about being able to take up nutrients, if we can release nutrients and we can get diffusion that's happening to where a plant can take it up right away, the plant can be releasing exudates, root exudates that are providing more food for the microorganisms. And then you see it there again in the center with the corn plant where you can actually see those root exudates next to them where it's kind of starting to drip. So those are definitely some of the things that start happening. So ultimately, as we do that, then we're influencing that soil biology or that soil microbiome as well. So when we think about just a few of the examples on the soil enzymatic activity, we think about, those enzymes catalyze the reactions during the nutrient cycling. So they're helping to get the microbiome to release the nutrients for us more effectively. So 3 of them that we'll focus on for today is if we want to have more sulfur mineralization, we need to have the aryl sulfatase. If we want to have better phosphorus cycling, then we have the acid phosphatase. And if we want to have better breakdown of the organic matter in the carbon cycle, then we need to have the beta glucodase. So as we start thinking about that with Bioz diamond, and we think about the enzymatic activity that happens, here we see that the beta glucodase has increased with the Bioz diamond in dark blue by 11%. The phosphatase has increased by 14%. And then the aryl sulfatase has increased by 16%. And this is across 13 different sites and a whole mix of different crops that you can see here on the left-hand side. So this is proving that the Bioz diamond is actually increasing the soil enzymatic activity within that profile. So it's actually enhancing the nutrient cycling. So what does that mean for us overall as we kind of try and bring some of these together? We start thinking about water-soluble fertilizers and 2.0 and what do we do next? We've already started with the precision and the source and the soil acidification, conditioning the water, making sure that we have clean irrigation lines. But we're thinking about it from the overall standpoint of what next. So we really want to provide a high value crop with these water-soluble fertilizers as a precision tool for growers. We want to manage the pH. We want to unlock the soil reserves, increase the nutrient use efficiency and the water use efficiency, as well as reduce cost to the overall system. So as we started thinking about growing more with less. And we want to think about shifting from not just the NPK to how do we use it as a tool, and also integrate the appropriate micronutrients and biostimulants or enhanced nutrient fertilizers that will boost the plant's resiliency and its uptake efficiency. And we're stimulating, and really looking at how can we feed the soil microbiome, how can we encourage it, how can we do the interactions of the two together. So, we look at some of our ICL innovations so far. Some we've talked about today is the PeKacid technology, and then also the Agrolution pHLow, as well as some on the Bioz diamond. As we've started looking at ways that we can unlock those nutrients and maximize the return on the investment. So growing more doesn't always mean adding more. In this case, we're adding much less as far as the total nutrients that we've been able to put on. We're unlocking what's already there in the soil so that we can think about it for better access in the root zone and for the plants and a smarter chemistry.
Well, thank you very much, Christy. So to follow up on that, we wanted to touch on, so what do we see as next for the water-soluble market? And what we see, at least related to North America, is a continued diversification of the offerings so that we can expand into new markets. So whether it be a unique new dry blend, a liquid offering, or new technologies, whatever they may be, that's what we at ICL and specifically in North America are focused on at this time. So I guess with that, we can move over into the questions section. Christy, if you want to come back on, we do have a couple, and you did such a great job talking about pH. There's a lot of pH-focused questions, as you could imagine. So the first one is, are acidic water-soluble fertilizers like PeKacid appropriate for use on soils that already have a pH less than 7?
Less than 7?
Yes.
Okay. So everybody's going to have to make their decisions individually on what they would want to do. If you recall back to the pear trial, we actually reduced it from where it was about 6.8, 6.9 down to 6.7. So just that small reduction in the pH, it's not a huge deal, but it's really about making sure that you're unlocking the nutrients in that root zone. So in the case for us, yes, sometimes it is very much worth it to do that slight precise fertigation so that we can reduce it in the root zone. We're not talking about changing it from a pH of 7 to a pH of 6.
Great, thank you. Can a foliar or a specialty water-soluble NPK product work for row crops, or are they most effective and efficient on the specialty food crops? And I think you touched on that a little bit with the discussion on Agrolution pHLow 114511, which is designed to be a row starter, but maybe you could touch on that bigger picture a little bit.
Yeah, for sure. So, we started obviously with the specialty crops and fertigation. That's the high value that comes in there. But from the trial work that we have done across the corn, soybeans, potatoes, and it continues on, then we definitely have seen very much of an advantage of putting the Agrolution pHLow or, a PeKacid type of a product, the 06020, where we're looking at doing it as part of the starter package. So I think that's really, you're trying to get the right nutrients right there when it needs it, get it off and going, so that when it gets a bigger root system, then after that it can take advantage of everything else that's in the soil. But we're trying to really help it get off and going and get a really good start for the row crops.
Great. There's another question. How do you see the future of the water-soluble market, and how will liquid fertilizer impact the water-soluble market? And I can take that one, Christi, and I can
Sure.
kind of give you our experience in the U.S. What we've seen evolve over the water-soluble industry over the last 10 years, I'd say, is historically there were more locations, whether it be retailers specifically, that would cut and blend and solubilize their own products on site. But with the cost of labor these days and other factors, we're starting to see the shift over to finished liquid tanks and other forms of storage. And so that's why we have started to offer the historically water-soluble NPK blends in a liquid form, so that we can service those locations that don't necessarily have the ability to solubilize themselves on site anymore. So I'm looking through all the questions, seeing if there's another one I can find. Here's one, Christi. It's more to education of pH focused. So in our projects, we often see a lack of experts with the necessary knowledge and skills in fertilizer development and production. What expertise and qualifications do you see as necessary for the development of pH-focused water-soluble fertilizers? And what's missing in the job market right now? Or maybe you could relate that into when, as an agronomist out meeting with customers, what is the main piece of knowledge that they're always looking for that you can provide them?
Yeah, so it's definitely a multifold sort of a question, I'd say. When I start thinking about if I was to be a new agronomist and coming on, what would I want to be doing? How would I want to be training myself? And you know, it's really, it's about understanding the chemistry in the soil, but it's also about the logistics of it from a practical standpoint. Because, you know, as Brian mentioned, sometimes you will have somebody that wants a liquid fertilizer and they don't want to mess with the dry water soluble. So it's about thinking about the science and understanding the science with it, but also having a practical understanding of what will work in those systems, what's going to make it easier for the grower to get it in place. From the standpoint of developing them overall and trying to come up with ones that will work, I think, you know, I'm certainly not a chemist that can understand all that. We would bring a chemist on board along with an agronomist and an operational person that would say how we would develop and innovate towards the future. I would encourage anybody that's starting off and trying to get going, that they would not only have the book knowledge, but then they would take it and they would apply it in a field setting. And then they'd go back and do the learning and back to the field setting and have the integration of the practical with the science.
All right, I think one more question here. How can I regulate the pH in alkaline soils?
So everything that we were talking about earlier, when you're talking about adjusting the pH, in the West here, we have very alkaline soils or high pH soils, a lot of calcium carbonate that are in them. So that is how we do it. We utilize the PeKacid straight, we utilize the PeKacid technology, and we have had huge benefits that come into that. You can, even in Nevada, where we have rough soils, we've been able to put the PeKacid on in alfalfa and be able to increase not only the yield, but the infiltration rate that happens from that as well. So we use it all the time for high pH soils or alkaline calcium, high calcium carbonate.
Well, thank you very much, Christi. I appreciate everything. Yeah, I think that was our last question. I think we can bring Simon back in to kind of wrap up here, and appreciate everyone for joining.
Yes, appreciate it.
Hello, can people hear me? Thank you, Christi and Brian, for what's really been a 30-minute crop nutrition masterclass. There's so much innovation going on at ICL, and we've been fortunate to cover some of this in Fertilizer International magazine. But I think taking a deeper dive and listening to ICL's product experts has certainly provided me with plenty of takeaways. I think that includes the realization that pH has such a critical role in nutrient retention and release in soils. And it's clear from today, I think, that from managing pH, yeah, it's definitely provides real dividends for growers here. It's also been great hearing more about what ICL's biostimulant range can bring to crops as well. through some of their complementary action and enhancing role. They also have this valuable function really as a kind of insurance policy for growers in times of crop stress. I think we all know that. And I think also talking about next steps for Water-Soluble 2.0, that's been really valuable as well. Anyway, I've come away with lots of thoughts here, and probably some further questions too, if I'm really honest. Because of that, I'd urge all of our webinar viewers today to reach out and follow up with Christi and Brian. Please do give us your feedback. Finally, I'd like to say, if you're interested in innovation, new products, sustainability, and crop nutrition, these are all very strong themes in Fertilizer International magazine. So if you'd like to learn more about the magazine and what our coverage can offer, then please do visit our website and sign up for a free trial. If you also follow me on LinkedIn, we've curated a selection of free-to-access articles to accompany the webinar. So yeah, please do that. Well, that's all from me. Thank you once again, Christi, Brian, and ICL for partnering with CLU on this webinar. We hope everybody has enjoyed it. So it's goodbye from us.
It's a pleasure to be here. Thank you.